how to say, a standard, few of the standard that are actually very useful when considering or designing HMI. Here I have shown few of the picture of HMI, what they are and how they are designed. This is one of the control station where you can see the control panel is shown here, but even though now the monitors are saying rain, but this is how the operator room will look like. This is one physical equipment layout where some of the status and CSL is displayed, and then there is one emergency operator system. Here in this design, you see multiple HMI screen, SCADA screen. They are displaying different screen of same software. So operator has a whole overview. This is another person of emergency operations. So I have picked up some of the information from Norwegian Norfolk Standard 1-002. In this standard, some important thing to note here. They call it safety and automation system to indicate the whole thing of PLC, HMI SCADA, and the panel, the control panel, and the communication cables, even the field equipment. They also include into safety and automation system. In this slide, I have shown one picture where the whole picture you can see it has FNG, ESD, FNG, INS, and then PDCS, PCS, and PSD. PCS 7, Siemens has one process control system. Some might know it as a DCS, distributed control system. 2 points I have picked up from this standard is one, test strategies, and that is it has three level of test. One is unit test, which is to test a small unit supplied by maybe one vendor and doing one particular thing. So that is the first priority and first level testing. Then second level testing is having multiple unit grouped together, and that is performing one common task. They are doing one kind of task that is grouped together. They're connected to each other very tightly, so that to be tested. And in this system test, there might be different vendor involved. So uh, the input output loops between the units to be tested as well. Integration test is the third level testing that involves all the systems and their connection. So after the integration testing, the system should run for at least 24 hours, and within that 24 hours, there should not be any alarm or failure to pass the whole system. And another important point I have taken from the standard is time response. So it has defined some of the uh, you know time response of the operator command, the closed loop control. These are defined as a maximum 2-second response time. Alarm display text, picture update, picture dynamic update. This also should be within two maximum 2 seconds. So alarm display text is 2 second, meaning that when alarm is occurred into the system, from that point of time and the popping up of the alarm text in the screen, and the time duration between these two is maximum 2 seconds. Picture update 2 second means when you are going from one screen to another, it should be complete within 2 seconds. Picture dynamic update is updating the tag values when you are in new screen. That should be also done within 2 seconds. So this is how this standard is very effective, and it will make a a consistent HMI design. Two things to be considered when designing HMI. One is technology-centered design, another is user-centered design. Technology-centered design focuses on equipment and its technology, what information it can, HMI can gather from the equipment, like calibration from HMI remote SCADA station, setting some values or diagnosing the control system or the equipment from the HMI. So this is a kind of equipment-centric design, and that to be avoided. User-centered design focuses on operator and ease of usage, and how the operator can respond to the event of the system. The goal of user-centered design uh, is that needs of the user. When user benefited from the design, actually the whole plant resource also benefited. It user predicts the future from that design, and then any event occurrence is reduced that way. Design should be such a way that user or operator able to predict the future event or fault, so that he can take action before it's going to happen. Even though it looks like future predicting, but yes, by trained or very meaningful design is possible. Okay, so why user centered design? So are we going to take feedback from the HMI operator and design as per their wish? No, uh, because operator might have ideas that is totally limited. He might not know the new and better design. So what feedback we should consider from operator? Yes, the operator can give good feedback about the experience, information, decision, working condition, and functions they need. What problem they face? They get the feedback useful from the operator. And some physical environment should be considered when developing new operator station or HMI, like lighting control elements, number of screens, keyboards, push buttons, lamps, indication. Uh, this ambience, when the temperature of the room, etc. This would be considered by designing HMI. Some other things also to be considered, like distraction-free control station, reduction of stress, reduction of fatigue, number of alarm and execution to be minimized, the number of screens to be limited, data overload should be avoided. The purpose of the use HMI designed to be to help operator doing his job in ease, and in such a way that he can take quick decision in case there is alarm, warning, event, or fault in the system. Every engineer who design HMI should go through at least few of the international standards before designing the HMI or SCADA. That will make some of the meaningful HMI design.